Good one. So there's two forms to write a polynomial or quadratic. We have the general form, ax squared plus bx plus c, which is sort of this sort of thing, 2x squared plus 3x plus 1. Okay, and then we have the standard form, which is the ax minus p, x minus 1 squared plus 2. Okay. What are the advantages of the standard form? What information does the standard form tell you? Tells you P and Q, which is the what? Yes. So the standard form gives you the vertex. What are the advantages of the general form? You can factor it to get the x and y intercepts, okay? So this is, and if you can't factor it, you use the quadratic equation, which you had to do on the quiz, okay? So they both have their positive and negative advantages. If you're looking for a quick sketch, and you just need x, y intercepts, if it's factorable, this is the best way. If you need to know the max or the min, if it's opening up, then you want it in standard form, okay? So we've looked at these independently. They're obviously, you can go back and forth. Now it's easy to go from this form, standard form, to general, because all you have to do is FOIL the brackets and then multiply everything, collect your like terms. The real question is, how do you go from this to this? And that's what we're going to learn right now, okay? So let's look at these are called perfect squares just for a sec here. X squared plus 4, or x plus 4, sorry, is x plus 4 times x plus 4. If you multiply that out, you get x squared plus 8x plus 16. And we'll do the x minus 5 all squared right here. So if you multiply that out, you get x squared minus 10x plus 25. All right, so do you see a connection? Actually, let's do, do you see a connection between the 8 and the 16 or the 10 and the 25? How can I get 16 from 8? So you could multiply it by 2. That's one way to do it. There's another way. Divide by 2 and square. If you take 8 and divide it by 2, you get 4. 4 squared is 16. Now let's see if that applies to the second one. If I multiply the 10 by 2, do I get 25? No, but if I get the 10 and I divide by 2, I get 5. And if you square it, you get 25. That's how you get perfect squares. You take the term with the x, you cut it in half, so you divide by 2, and then you square it. And you create perfect squares. So if I'm going to go down to C here, x squared plus 2x plus 1. And I said, make it a perfect square. You take the 2, divide by 2. What do you get? 1. What's 1 squared? 1. So if I put a 1 right there, it's a perfect square now. And then that would factor to x plus 1, x plus 1. If I have x squared plus 18x, I don't want to make it a perfect square. What's half of 18? 9. What's 9 squared? 81. So if I have an 81 there, and then I say factor it, you're asking yourself, what multiplies to 81 and adds to 18? It's 9 and 9. So you can write x plus 9, or you can just write x plus 9 all squared. You can even do it if it's not a whole number. So what's half of 3? Let's do it as a fraction. Okay, and it's 3 over 2, right? And then you square it. So if I just write, what's 3 over 2 squared? What's 3 squared? 9 over 4. You just square each one, right? So if I put a 9 over 4 there, that is now a perfect square. What would the factored form be? X plus what? What multiplies to 9 over 4 and adds to 3? 3 halves. It's whatever half of this is, the middle term. So this would factor to x minus 3 halves, x minus 3 halves. Why is it minus or subtraction, negative? Yes, because the 3 is negative. Okay? So we'll do the last one. X squared minus 1/4 x. What's half of a quarter? An eighth, right? If I divide this by 2, I get an eighth. What is 1/8 squared is what? What's 1 squared? What's 8 squared is 64, so it's 1 over 64. So that looks really complex, right? But if I said to factor it, you know that it's going to be, because it's a perfect square, x minus what? 1 over half of the middle. Okay? So it's x minus 1/8. Now look, you can do it with decimals, and we'll do it with decimals when we do some examples, okay? That's fine, I don't care. All right, we are going to use this technique to complete the square. Okay, we need to make a perfect square. Can I turn the page? All right. So good point. May I turn the page? Okay, here we go. So they write the steps out. I'll write them out off to the side. Y is equal to x squared plus 10x plus 16. We need to turn this into completed square form, which is just standard form. This. That's what we want. Okay, step 1. So I'm going to add a couple steps. Bracket first 2 terms. So basically, I put brackets around the first 2 terms like that. X squared plus 10x. Second step, take half, and let's say divide term with the x by 2. So you kind of do that in your head, or you can write it off to the side if you want. So what's 10 divided by 2? 5. Okay. Square. I'll just say square number 2, if that makes sense. Square step 2. Okay? You know what I mean? When I say that, square step 2. And then, and this is the trick, and then add and subtract it. So this is what it looks like. Half of 10 is 5. What's 5 squared? 25. So I add 25 and I subtract 25. And this is all inside the brackets with the 16 just hanging on the outside. Why do I need to add and subtract it? What's 25 minus 25? 0. If you add 0 to anything, does it change its value? No. That's why you have to add and subtract it. We have not changed the value of this expression because we've really just added 0 here. Okay, we've just written the 0 in a different way. So everything stays the same, it just looks different. Now, fourth step. Take the negative outside of the brackets. The positive stays in all the time, the negative comes out. Negative leaves the brackets. That. Final step. Simplify, so collect like terms of the 25 and the 16, and factor the brackets. But the brackets are always going to be a perfect square because we cut this in half and squared it. So in other words, we're saying, well, it multiplies to 25 and adds to 10. 5 and 5. So it becomes x plus 5 all squared. Negative 25 plus 16 is negative 9. And you've now, so step 5 is factor and collect like terms. And now you have it in standard form. Which means you know the vertex. What's the vertex? Negative 5, negative 9. So negative 5, they're not asking us to graph it, but we'll do it. Negative 5, negative 9. Does it open up or down? Up. There you go. All right. That's all there is to it. I mean, we're going to add one more wrinkle, but it's just one extra step, and it's not actually too difficult, but I want to practice on this one here. X squared minus 9x minus 20. Okay, we're going to convert this to standard form. Ax minus p all squared plus q. First step is to what? Bracket the first two terms. Okay, now what? No, before you square the 9, you have to divide it by 2. Okay, so we'll do it in decimal form because I know people like decimals. So what's 9 divided by 2? 4.5. What's 4.5 squared? 20.25. Okay, so 9 over 2 is equal to 4.5. And then you square it, and you get 20.25. So that gets added and subtracted in the brackets, and then negative 20 is just hanging on the outside. Which one comes out? Now what? Factor the brackets. What do the brackets factor to? What multiplies to 20.25 and adds to negative 9? 4.5 is always half the middle term. It's always going to be this term here. So it becomes, is it plus or minus? Minus, because it's a negative 9. So it's x minus 4.5 all squared. Negative 20.25 minus 20 is negative 40.25. And there you go. This, you just have to practice it a few times, and then you will get the hang of it. I would like you to do question 3, A to E, please. The only wrinkle that we're adding here is we don't have a 1 there anymore. We have a different number. Everything's the same except for 2 steps. The very first step is, again, bracket, but then you factor out whatever that leading coefficient is. So in this case, I'm going to factor out a 3. So I get f of x is equal to 3 x squared minus 6x, and then the 20 is there. Do not bracket the 20, leave it alone. You're just factoring out from the first 2. Okay? Now it's the same. So what's half of 6? 3. What's 3 squared? So you add and subtract it inside the brackets. Okay? Everybody with me so far? Here's the second change. What number comes out? The negative. But when you take it out, you have to multiply by the number that's out there. Okay? So when you bring the negative out, you multiply it by 3, what do you get? 27. So on the outside, you now have negative 27 plus 20. Because it's 3 times all this stuff, so if you expanded it and put the 3 into everything, you'd have a negative 27 there anyway. And like, you can do this. Don't write this down, people. If I multiply that 3 in, I'd get this. Like that, right? And then I'd say, okay, well, now we have to factor this bit. So the 27 is outside. Okay. All right? So instead of having, and then I'd have to take the 3 out and then do factoring on that. Okay. So we go backwards, but we can save ourselves time just by multiplying by the 3 as you bring the negative back up. Okay? Okay. Now, factor the brackets. What do they factor to? Negative 3 and negative 3. So x minus 3 all squared. Negative 27 plus 20. Negative 7. And that's your answer. So only 2 things change. One, you have to factor something out at the beginning, the a value. And when you pull the negative out of the brackets, you have to remember to multiply by whatever that a value was. Okay? That's what people forget. I just want to do this one, and then this lesson's over. We did a couple questions. This lesson's over. Negative 2x, or 7 plus 10x minus 2x squared. What's wrong with the way this is written? It's not wrong, but it's, yeah, we usually don't write it this way. So flip it around. To that. Now, what am I factoring out? Or what do I bracket, I guess? Bracket the first 2. What am I going to factor out? Take the negative with it. Okay? So you're going to pull the negative 2 out. What does that do to the signs? It flips the signs. Okay? Now it's the same process. What's half of 5? 2.5. If you square 2.5, does anybody know what you get? 6.25. Which one comes out? What do you have to do when you pull a negative out? Multiply by the negative 2. So then you get positive 12.5 on the outside. Okay. Factor the brackets. X minus 2.5 all squared. Combine your like terms. 19.5. Does that open up or down? Down because of the leading coefficient being negative. Questions? So we just added 2 little wrinkles to it. We're all good? Numero 5, please. Different methods of sketching a quadratic equation or a quadratic function right now. Okay? So if I give you the function x squared minus 8x plus 12, and I said sketch it, you have 3 choices. All right? The first choice, and if I don't specify anything, the first choice I would do is to factor it. All right? See if it's factorable. Is this factorable? Yes. What multiplies to 12 and adds to negative 8? So x minus 6 and x minus 2. So what piece of information does that give you? What piece of information about the graph is this? Not the y. These are the x-intercepts. What makes each bracket 0? So x equals 6 and 2 are your x-intercepts. Can we get the y-intercept? How? Make all the x's 0. In other words, it's the constant term, right? That's your y-intercept. So then we have x-intercepts, we have the y-intercept. We could sketch it quickly. 2, 6, our y-intercept is 12. We've marked 12. Does it open up or down? Because that's positive, right? If it was negative, it would open down. So the graph looks something like that. What piece of information does it not give us? Yes, it doesn't give you the vertex, right? However, you can find the vertex through this method. It's a bit more work though, okay? So I'll just show you. I won't ask you to do this, but you can do it. If you know the x-intercepts, the vertex is the average of the x-intercepts. So average of the x-intercepts, which is going to be 2 plus 6 divided by 2. You have 2 terms, which is 8 over 2, which is? So your vertex is at 4. So that'll give you the x value of the vertex. I'm not going to do it, but how would you get the y value of the vertex? What would you have to do? You have to put this into the equation, okay, and do that. I'm not going to do it because what's the other method of finding the vertex? If I said, I want to know the vertex of this graph, what would you do? Say we didn't have the graph. Sorry? Yes, you complete the square, so this is converting to standard form. Because sometimes you want it. You want to know what the height of the vertex is. Okay? This just gave me the midpoint between these two. It didn't give me what the y value was, which you can find. But if it's more complex, it's usually easier to convert to standard form. So this is what we just did. We have y is equal to x squared minus 8x plus 12. All right, convert that to standard form, peoples. Please. That's exactly what we just did. There you go. So what's our vertex? 4 and negative 4. The P and Q values. P and Q. All right, which matches what we did up here. When I averaged them, I got positive 4, so we know we're doing it right. So this gives us the vertex. When do you use the quadratic formula? When it's not factorable. I mean, the reality is you could use it all the time if you don't like factoring, because the quadratic formula will work. So we'll use it on this just to show you. So remember the quadratic formula is negative b plus minus b squared minus 4ac over 2a. And remember, it goes a, b, c. So I'll let you plug it into the formula. I'll do it as well, and we'll see if we get the same answers. We should get 2 and 6, right? This should give us the x-intercepts, because it's like factoring. So we should get 2 and 6. Let's see if it works. I hope it does. Whoops, what happened there? What the heck happened? There we go. You get 2 and 6? All right. Just watch your signs here. And remember, it's plus or minus square root of 16. Square root of 16 is 4. So let's say plus 4 divided by 2. 8 minus 4 divided by 2. Okay? So you have 3 methods of sketching a quadratic function. If I don't specify on the test which method to use, do whatever you want. I don't care. Okay, it's up to you. If it's factorable, factor it, get the x-intercepts, y-intercept, sketch the graph. If I say I need to know the vertex, okay, then completing the square is probably the best way to do it. And obviously if it's not factorable and you need the x-intercepts, this is what you have to do. But if it's not factorable, you can always complete the square as well. Okay? Just doesn't give you the x-intercepts. All right. I will. Anybody have any questions about that stuff? No. Okay, I'm going to go over the quiz quickly. Tomorrow, we have to do one tiny lesson, which is word problems. The applications of all this. We're just going to do straightforward ones. We're not going to do crazy ones. Then I'll give you time to review, and your test is on Monday. Yeah. It won't have the rational, it'll just be all quadratic stuff. But I'll outline what you'll. Partly graphing. Sorry? You don't like graph? I don't know what to say to that. Addition? What do you mean addition? 2 plus 3 is equal to? Yes. And then how many does he need?